the school bell is given, let's start. It's time for our science class. Children, do you really miss all those wonderful things about our school? Yes, the school bell, the assembly, the switching of classes. And how do you know that a particular period is ended? Yes, it's because it's by the sound of the bell, right? So what did I do just now? I produced sound by hitting a plate with a spoon or knife, right? Okay, children. So today we'll be learning about sound, okay? We hear so many sounds from our surroundings, like the calling of a bell, the ringing of our telephone, the noise of the vehicles, and so on, right? So today we'll learn how the sound is produced, what exactly sound is, and how the sound is produced. Are there any different kinds of sounds that are produced? Is there any differences between different sounds? And so on, children. Today we'll recapitulate all that we have learned in our last week, children. Okay? So to begin with, what is sound? We all know that sound is a form of energy that travels through a medium. It requires a medium to travel, children. It does not mean that the medium itself moves from one place to another. Only the energy moves from one place to another. Very important point to remember here. The disturbance, or nothing but a sound travels in the form of a wave or a disturbance. It's a form of energy. So in other words, we can say that the energy travels from one place to the other. I'll give you one small example. Just consider a pond, okay, still water, and you throw a stone into it. What happens? That stone creates ripples around it, and it moves in the form of waves towards the ends, right? So does the water move from the center to the ends? No, the medium does not move from the center towards the ends or the corners, but the wave or the disturbance moves. Did you understand, children? So this wave or nothing but the disturbance is nothing but energy. So energy, that disturbance, it moves from the point of contact towards the end or the corners. It just spreads like this. The ripples spread. Have you seen any time, children? So only the energy moves from one place to the other. In the similar manner, sound is also a form of energy, and that energy, it moves through the medium from one point to the other. So anything is, when I am speaking, how are you able to listen? Because between me and you there is a medium, nothing but an invisible medium, which is nothing but air medium, a medium of air, right? So now these sound waves, they travel through this medium and reach your ear, right? So here this energy is moving. It's not that the air is entirely moving and entering in your ear. That's not the case. Only the energy moves and you are able to hear. So that is what is sound all about. Sound is a form of energy which travels in the form of waves from one point to another. It requires, we have been learning this since our childhood, right? So that sound requires a medium to travel. So in vacuum, what is vacuum? Already I taught you. Vacuum is nothing but it's a region or a place where there is no matter at all. Where there is no matter, no medium, we call it as vacuum. So sound does not propagate. Propagation means traveling. Sound does not travel through vacuum, children. Okay. Because it needs a particular medium. Any medium. It can be air medium, it can be solid medium, it can be gaseous, solid, or liquid medium, children. And sound travels fastest in solid medium and slowest in air medium, children. Okay. See here, children, based on whether a particular form of energy requires a medium or not, whether a wave requires a medium or not, waves are actually classified into two types, okay? Please, it is for your understanding that I am saying. It's not there in your textbook, but please do listen and get some idea. Ultimately, it is the subject that you have to learn, not just what is there in your textbook. This will give you nice information. You will have nice concept in your minds how these waves travel and all that. Okay, please, what all I teach today, it's not there in your textbook, but you have to learn it in order to understand the sound chapter in a more perfect way. Okay. So that depending upon whether a wave requires a medium to travel or not, waves are divided into two types, mechanical waves and electromagnetic waves. Mechanical waves are those waves which require a medium, for propagation. So if there is no medium, they won't travel. So can you give an example for such mechanical waves? Yes, it's our chapter only. It's nothing but sound. Sound is an example for such wave where if there is no medium, the sound waves cannot be, they cannot travel. So mechanical waves are those waves which require a medium to travel. And electromagnetic waves are those waves which do not require any medium. They even travel through vacuum. And we know the best example for electromagnetic waves are nothing but light waves, right children? So the light waves, they travel even through vacuum also. So they don't require any medium. So today we'll be concentrating more on the mechanical waves, children. Mechanical, we can say, if I just ask you to write something about sound, then you have so many points to write about sound. We know that sound is a form of energy. It travels from one form to another. It propagates through a medium. So that's why it's called as a mechanical wave. And how is it produced, children? It is produced by a vibrating body. Already I taught this in my previous videos. So it is produced by a vibrating body. So when I used this plate and when I just struck it with the help of this, what happened? It created vibrations in this plate, and because of that the sound was heard. If you just stuck it, and then if you touch it now, you will see that you can feel the vibrations, and because of those vibrations only you could actually hear the sound that is produced by the plate. Okay, now try doing the same thing with different plates. Like you take a plastic plate and you hit it with the same spoon, then you hear a different sound. You take a wooden piece or a block and then you hit it with something, then you hear a different sound. Because it is metal, because it is solid, the material is different, it produced loud sound, right? So sound is basically produced by vibrating bodies. That you have to remember, children. Coming to the waves again, there is one more classification, very important classification, and that is mainly based on the particle of the medium, children. How the particle is vibrating. I told you that first the vibration happens and then sound. Because of the vibration, the sound is produced. Now vibration, what is vibration? To and fro movements of the particles of the medium, right? So I told you this plate, when it is struck, what happened? It vibrated. Each and every point or particle of the plate vibrated. How it vibrated? Depending on that, we have two types of waves. Transverse waves and longitudinal waves. We'll see an example. Can you see over here? Just see the ripples on the water surface. Ripples on the water surface, you can see they will be like this, right? Once it is disturbed, when you drop a stone in still water, what happens? You can see the formation of waves over there. You can see that the water feels like, going up and down, and this wave, it proceeds from the point of disturbance towards the end. It just spreads out like this in all the directions, equally in all the directions, and that is why the ripples in the water. For example, you take a bucket of water and then you drop a stone here. Then what happens? Slowly you can see the disturbance moving like this in circular fashion from the center to the outer edges like this, right? So now we have to consider two important things. One, the direction of the wave, and the second one, how the particles of the medium are vibrating. Now you see, the direction of the wave is in this direction, from the center towards the end like this. From the center to, this is the direction of the wave. That means the energy is flowing from this direction to this direction, like this, in this direction, from left to right. Now, how are the particles of the medium vibrating? I just showed you in my last video that you consider any one point, you drop one thermocol ball or a plastic ball that floats in water. What happens? You can see that once it is disturbed, it moves up and down. Have you seen that? It moves up and down, and that is perpendicular. How does it move, children? Vibration happens in this manner. It moves up and down. This is perpendicular to the direction of the wave. So what is happening here? The particles are vibrating in a direction perpendicular to the propagation of the wave, direction of propagation of wave. The wave is moving in this direction, whereas the particles are moving up and down. Did you get that? So that is called as transverse wave. Now, the examples of such waves are nothing but light waves, children. Light waves and surface ripples of water, they are the examples for transverse wave. When coming to sound waves, it is different, children. We classify sound waves as longitudinal waves. So, here the situation is quite opposite. You can see here it is perpendicularly, it is moving with respect to each other, right? But here if you see, you can see sound waves. This is the way how the sound travels from one place to another. You know, this is the medium. For example, it can be an air medium or water medium or any gas, solid medium. What happens? The waves move in this direction and the particle, like you consider any particle, okay, how do they vibrate? They vibrate to and fro in a direction parallel to the direction of wave. Can you see here? The particle is vibrating like this and the wave is vibrating like this. Both are parallel. But in this case, the particle is vibrating like this and the wave is moving like this, perpendicular. So that is the difference. An example, the best example for longitudinal waves is sound waves, children. So hope you understood some points about sound today. Tomorrow I am going to take up some more topics about sound. Okay, children? So if you have any doubts regarding it, please message me. Thank you.